Hello everyone. Today we're going to be looking at 8.1, graphs of sine and cosine functions. So the sine and cosine functions are called periodic functions, which means that their graphs are going to repeat after a specific interval. So if you look at the graph below, you can see that if you pick this point as your starting point, it will go up to 1, back to 0, down to -1, and then back to 0. And that completes one full period. So the period would be from 0 to 2 pi. And same for the cosine function. If you look at this cosine function that's right below, you will see that if you start at the y-axis, it'll start at 1 instead of 0, goes down to 0, down to -1, back to 0, and back up to 1. So it starts here, and it completes one full cycle from 0 to 2 pi. So in both cases, the period is going to be 2 pi. So period for both of these graphs will be 2 pi, sine and cosine. So that's called, they use the letter P to denote the period. So we're going to, the smallest such positive number P is called the period. Okay, very good. Let's move on to the next. If you look back at the graph, you will notice that the arrow indicates that it just continues indefinitely in both directions. It'll oscillate from 1 to -1, 1 to -1 in both directions for both sine and cosine. So if you will see the range, that refers to the y values. The highest or the lowest y value for both of the graphs is -1, and the highest y value for both graphs is +1. So from -1 to +1, that graph, you will see that there is symmetry over the origin. Take this point, for example. If you were to reflect it over the origin, it would reflect down here. So any point is a reflection over the origin, and it'll just match directly across from the origin. Whereas the cosine graph, if you look at the cosine graph, it's actually symmetric over the y-axis, because this part is symmetric over the y-axis. If you were to fold the paper, if this were paper and you were to fold it over the y-axis, this part of the graph will go directly above, coincide directly over this side of the graph. So that's gauge. So the period of the sine function we just saw is 2 pi. The period of the cosine function was also 2 pi. The domain for both sine and cosine function will be, both of these cases, the domain is going to be -infinity to +infinity. And the range, if you go back to the graph, would be our range. So let's write that. Inclusive, -1, comma, +1, inclusive. Symmetry. Sine is called an odd function because it's got the feature such that when you take the sine of a negative angle, that's going to equal to the negative of the sine of the positive angle. So that means that when you have an odd function, you're going to have symmetry about the origin. The cosine function, on the other hand, is called an even function because it has a feature such that when you take the cosine of a negative angle, it's going to equal the cosine of the positive angle. So that's called even. So the difference is that sine, you would multiply it by a negative, and cosine, you would not. So in this case, it's going to be symmetry over the y-axis. So the general form of any sine or cosine function, which you can call them sinusoidal functions, but I just prefer to call them sine and cosine functions personally. They're going to have a general form that looks like this. The A, B, C, and D, those values are going to affect the graph in some way, which you will see. So let's continue. Let's start with the amplitude. So the amplitude represents the vertical stretch or compression of the function. So you can stretch the function vertically or compress it vertically by changing the value of A. All right, so that's what amplitude stands for. So the formula for amplitude is just going to be the absolute value of A. So whatever your A is, that's going to be, and you take the absolute value of that number, that is your amplitude. To find it based off of a graph, you would take half of the difference of the maximum and the minimum. So let's write that in. The next variable would be b, and what the b is going to tell us whether the graph stretches horizontally or compresses horizontally. It's going to affect the period of the graph. So the period will be affected by the letter b. And there is a formula for the period, which is really nice. The formula is 2 pi divided by the absolute value of b. And then after you get the period, you'll be able to figure out what the increments are. The increments are going to tell you where to plot the points. And you're going to need a total of 4 increments. So we'll get to that. So here we go. Here is our first exercise. They want us to determine the amplitude and period of the following function, then graph one period of the function. So let's start with the amplitude. So the amplitude is, if you recall, is amplitude is equal to absolute value of a, which in this case is the absolute value of 1, which is simply 1. And that is because there is no number in front of sine, so if there's no number here, that means that's a 1. All right, the period, let's go and figure out what the period is. The period is 2 pi over absolute value of b, which is 2 pi over absolute value of pi over 6, which is 2 pi over 6, which is 2 pi times the reciprocal of the denominator, which is 6 over pi. And now, as you can see, the pi's will cancel. That's how you divide a fraction. You multiply by the reciprocal of the denominator, and you should end up with 2 times 6, which is 12. So the period is 12. Now we can find the increments. So the increments are going to go from, the increment formula is p over 4, which in this case is 12 over 4, which is 3. Now we can begin to graph. So we're going to start at 0. That's going to be our starting point. Then we're going to go to our first increment, which is 3. Then we're going to go to our second increment, which is 6. You just keep adding 3 the increment, and then 9. And then the last one should take you to the period, because we're starting at 0 and we should end at 12, which is exactly what we get if you add 3 4 times. The amplitude is 1, so let's label the height of this function is going to go up to 1, and the lowest value, since the amplitude is 1, is going to go down to -1. So to graph, you would simply start at 0 because of the sine function. Sine starts at 0, then it's going to go up to the +1 at the next increment, and then at the next increment, it'll go back down to 0. Then at the next increment, it'll go down to -1. And finally, at the last point, you go back to 0. Then you can complete your period by connecting the points in a nice curved line. Let's check our graph using Desmos.com. As you can see, the screenshot from Desmos shows that the graph does look somewhat like the graph that we drew. It's a little stretched out in Desmos just because I pinched out, and so I zoomed out, and so it looks a little stretched out, but it's actually the same if you look at this at the x-axis. Let's move on to the next page. So for this example, we need to find the amplitude, the period of this function. So let's do the same thing that we did in the previous example. So start with the amplitude. Well, actually, we should start by labeling things. As you can see, A is -4. B, since there is no number in front of the x, it's a 1. So there is a 1 there. So B is going to be 1. All right, so the amplitude is equal to the absolute value of A, which is the absolute value of -4, which is 4. Okay, now let's find the period. The period is given by the formula 2 pi over absolute value of b, which is 2 pi over 1. Absolute value of 1 is 1, so it's just going to be 2 pi. Let's find the increments. The increments, as you recall, should be p over 4, which is 2 pi is our period, divided by 4. We can simplify that, and that becomes pi over 2. So our increments are going to be pi over 2. So now we can start to graph this function. So we're going to start at 0 once again, and then our first increment would be pi over 2. And then if you add pi over 2 to that, you're going to get a pi. And then if you add pi over 2 to that, you'll get 3/2 pi. And then if you add pi over 2 to that, you will get 2 pi. So what I'm doing is I'm just adding pi over 2, and that gives me pi. And then I add pi over 2 to that, and then I get 3/2 pi. And then if I add pi over 2 one more time, I will get 2 pi. So I'm just continuously adding pi over 2 4 times in order to get to the end of the 1 period. Since the amplitude is 4, we got to go up 4 tick marks. 1, 2, 3, 4, and down 4 tick marks. 1, 2, 3, -4. So -4, +4. For sine, you start at 0, so our first point is at 0. And because in this case, a is a -4, if it's a +4, you would have gone up to +4 and then 0 and then down to -4 and then back to 0. But because it's a negative a, that means you're going to go down first. The sine graph will go down first instead of up first. So our next point should be down at -4 at the next interval. At the next interval goes back to 0. Sorry, the next increment. And then the next increment, it should go back up to +4. And then at the last increment, it should end up back at 0. And that completes your cycle or your period. Let's check our answer with Desmos again. And as you can see, it looks pretty identical. The next values that we're going to look at are constants c and d of the general form. And those two values are going to determine both the horizontal and the vertical translations of the graph. So the midline is what goes right through the middle of the graph. So that's why it's called midline, and that will determine your vertical shift. If the graph moves up, then that's a vertical shift, or the graph can also move down. So it's going to be a horizontal line, which means that the form is going to be y is equal to d. So whatever d is, that is your midline. So if the d is positive, that means the graph is going to shift up. And if the d is negative, that means your graph is going to shift down. Okay, there's also what's called the phase shift. That's just a horizontal translation or a horizontal shift. So the phase shift is a horizontal displacement. And so the formula for that is given by c over b. And so if c over b is positive, then the graph will shift to the right. And if the c over b is negative, then the graph is going to shift to the left. So let's look at this example here. All right, so they want us to find the midline, the amplitude, the period, increments, phase shift, and sketch the graph. Let's start by writing out the general form of a sine function. The general form is a sine parentheses bx minus c plus d. So notice that our function looks somewhat like it, but the big difference is that this has a plus and the general form should have a minus. So you always want this to be a minus. So we can force it to be a minus by simply writing this f of x equals sine x minus negative pi over 6. Because now you have a double negative, and that double negative will turn into a positive. So this is basically identical or similar. It's equivalent. It's just that this is minus a negative, which actually turns into a plus, so it's equivalent. But now we have it in the form that we need, and now we can identify our A, which is 1, our B, which is 1, our C, which is negative pi over 6, and our D, which is negative 2. So let's write all that out. A is 1, B is 1, C is negative pi over 6, and D is negative 2. So you do want to always do that whenever you have a plus instead of a minus. Always write this as a minus, a negative, and then you can identify your C. So in this case, C is negative. All right, let's start with the amplitude. So the amplitude will be, actually we can start with the midline. Let's start with the midline. It doesn't really matter what you start with, but I'll start with the midline. The midline, remember, is y equals d. D is negative 2. So we got our midline. Right, now let's move on to amplitude. The amplitude, I'm just going to call it amp, is the absolute value of A, which in our case is just the absolute value of 1, which is 1. Let's go with period next. The period is 2 pi over absolute value of B, which is going to be 2 pi over the absolute value of 1 is just 1, so it's just going to be 2 pi. Let's go with the increments. The increments are period over 4, which is 2 pi over 4, which is pi over 2. So we're going to increase by pi over 2 each time to get to the next increment. Now let's find the phase shift. So the phase shift, we'll just call that PS for phase shift, is C over B. C is negative pi over 6, and B is 1, so that's just going to be negative pi over 6. So the phase shift is where you start your graph. That's where we're going to start. So now we're going to add the increment to the starting point. So we're going to take negative pi over 6 and add 2 pi over 2 to that. And if you do that, you should get common denominator of 6. So times 3 times 3, you get negative 1 pi plus 3 pi, which is 2 pi. That would simplify to pi over 3. So our starting point is negative pi over 6. And then our next increment would be pi over 3. Now we got to add pi over 2 to that to get the next increment, because that is our increment. So once again, the LCD would be 6. So times 2 times 2 times 3 times 3. We get 2 pi plus 3 pi, which is 5 pi over 6. That would be our next increment, 5 pi over 6. And we do that again to find the next increment, plus pi over 2. Once again, the LCD is 6, so times 3 times 3. That's going to be 5 pi plus 3 pi, which is 8 pi. And that simplifies to 4/3 pi. So that'll be our next tick mark, 4/3 pi. And remember, we got to do that 4 times, so we have to add that one last time. So let's add pi over 2 one final time, and that's going to give us an LCD of 6 once again. So times 2 times 2 times 3 times 3, that's 8 plus 3 pi is 11 pi 6. So that's going to be our final point for one complete period, 11/6 pi. And since we are working with the sine graph, that means our starting point will be at 0. Oh, actually, we forgot our midline. Our midline is at negative 2, so we got to start there, actually. So let's start with our midline. So let's do a couple tick marks. 1, 2. That's negative 2. So our midline should be here. I'll do that in red. I like to dash it So I'm just going to dash it. Okay, so there is our midline. That is y equals -2. All right, so the way we would finally draw our final graph would be we start at the phase shift on the midline. Since it's sine, you have to start at 0, which is basically the midline. And then you're going to go, the amplitude is 1, so that means we're going to go up 1 unit for the next increment. And then you're going to go down back to 0, which is the midline, for the next increment. And then you're going to go down to 1 unit down, which would be -3. That would be at the next increment, -3. And then finally, at the final increment, you go back to 0, which is the midline. And now you can connect those points in a smooth curve. And that is our final answer. Let's check our graph with Desmos. And as you can see, it does look pretty identical to the graph on Desmos. So we did it correctly. Let's continue on to the next problem. So here's a summary of what we've learned so far. So here's a general form of a sine function. Same thing goes for the cosine. You can just replace sine with cosine, but it's the same general form. The amplitude is the absolute value of A. The period is 2 pi over the absolute value of B. The increments are determined by the period divided by 4. The phase shift is C over B. And finally, the midline is Y equals to D. And remember, if this is plus, then you want to just convert this to plus a negative so that your C will be the correct sign. Okay. Let's look at the next example. So determine the midline, amplitude, period, increments, phase shift, and sketch the function. So once again, let us start with identifying the A, B, C, and D. So A is 3, B is 2, C, well, notice there is no C. If there were a C, you would see something either plus or minus a value, but since there's no plus or minus after the 2x, that means C is 0. So C is going to be 0 for this problem. And as you can see, D is equal to +1. So let's start with the midline this time. So the midline is Y equals D, which is +1. Let's move on to the amplitude. That's going to be absolute value of A, which is absolute value of 3, which is 3. Let's go to the period. That's going to be 2 pi over the absolute value of B, which is 2 pi over 2, which is just pi. The increments are going to be the period divided by 4. So the period is pi, and the increments is pi over 4. Lastly, the phase shift, I'll call that PS for phase shift, is going to be C over B. The C is 0, and the B is 2. 0 divided by 2 is 0. So now we have all the information we need. We have the midline, amplitude, period, increments, and phase shift. So let's start with the midline. So we go to our graph, and let's put some tick marks here. So we got -1, -2, -3, etc. for +1, 2, 3, 4. So the midline is going to go right through +1. We'll do that in black. Remember, I like to dash it. I recommend that you dash it too. All right, so that would be Y equals 1. All right, now we start with the phase shift. The phase shift starts at 0, so that doesn't change. That's going to just be right at 0. And then the next one is the increment. So we have to add pi over 4, which is just pi over 4. So that's our next one, our next increment. And then we have to add pi over 4 to that. If you add pi over 4, you're going to get 2 force pi, which is really pi over 2. And then if you add pi over 4 to that, you're going to get the next increment, which is, well, you get a common denominator, which is 4, which means times 2 times 2. So you're going to get 2 pi plus 1 pi, which is 3 pi fourths. And finally, the last one, we have to add the increment one final time, and you're going to get 4 fourths pi, which is just pi. All right, very good. So we do have a sine function once again. So since we're starting at 0, your starting point is 0, you're going to put your first point down right on the midline at 0 for sine. If it had been cosine, you would have started at the amplitude, which is 3. So from the midline, you'd go up 3 units. 1, 2, 3. You would have put a point here for cosine. But since we're dealing with sine, it's 0 first. And then if it's a positive 3, that means you're going to go up first. If it were a negative 3, then you would go down first. So now we have to go to the next increment, and we have to go up 3 units. So that's going to be 1, 2, 3. So at pi over 4, you would go all the way 3 units up. And then at the next increment, you go back to the midline. At the next increment, you would go down 4 units from the midline. 1, 2, 3, 4. So that would actually take you to negative 3 because you're counting 3 units from the midline. Actually, that would not be correct, right? It would be if you go down 3 units from the midline, it would be 1, 2, 3. So you'd be at negative 2, actually. So I'm glad I caught that. And then back to 0. So you should be going up from the midline, 1, 2, 3 units, and then from the midline down 3 units, 1, 2, 3. All right, and then you just connect those points in a nice smooth curvy line. And there it is. Now let's check our answer with Desmos. And as you can see, the graph does match up to the graph on Desmos, so we did it correctly. The last thing we're going to do in this section is we are going to write an equation given a graph. So we're going to do the opposite. Instead of them giving us a function and us graphing the function, they're going to give us the graph, and we're going to have to come up with the function. So the process is the same process, but in reverse. Okay, so when determining the equation of a sinusoidal function from a graph, it's helpful to first find the midline. So let's find the midline first. Once we have the midline, then we can figure out the amplitude and the period. And then we have to decide whether we're going to use a sine or a cosine. You pretty much can use either because they are very similar, the only difference being the phase shift. But let's see what we decide for this first graph. And then the final thing would be the phase shift that would be the final thing we look for. So let's go ahead and start with the midline. So if you're looking at this graph, you should be able to determine that the midline looks to be about right at 2. So let's draw it in. There's our midline, y equals 2. So that's our d. So we have d is 2. All right, now we can figure out the amplitude. The amplitude isn't too hard. If you look at the graph, the amplitude, if you recall, is the value from the midline to the highest point. So from 2 to 3, that's 1 unit. So that means that's your amplitude is 1. You just take the highest point minus the midline. So 3 take away 2 is 1. So A is 1. And then you have to figure out whether it's positive 1 or negative 1. Well, because it's going up first, that means that it is going to be positive. If it had been going down first from 0, then it would have been negative 1. But since it's going up first, then that means it's positive 1. Okay, the next thing we need to do is find the period. So let's write the formula out. If you recall, the period is equal to 2 pi over b, or the absolute value of b, well, we can find the period simply by looking at the graph. So let's look at the graph and determine what the period is. So the period is going to, let's say we start at this point. You can start anywhere you want, but a convenient point most of the time is the y-axis. So as you can see, we can say that we start our graph here, and then it's going to go up, down, and then it's going to go back to 0 at this point. So from 0 to 2 pi is one complete cycle. So it looks like it's going to be, the period would be 2 pi, because if we start here, you trace until you get back to your starting point. So there it is. So one period is 2 pi. So now we've determined that the period is 2 pi, so p is 2 pi. So now we have to solve the equation for b. So to solve, you have to isolate b, right? So in order to isolate b, since b is in the denominator, you want to multiply both sides of the equation by b. That's going to allow us to cancel the b's out. And now we're going to have 2 pi b equals 2 pi. Final step to solve for b is divide both sides of the equation by 2 pi. And that gives you the b. 2 pi over 2 pi is just 1. So now we got our b. We have a, we have b, and we have d. The last thing we need to find is c. So to find c, we're gonna look at the phase shift formula. So phase shift is equal to c over b. If you look at the graph, notice that if we start here at the midline at x equals 0, there is no phase shift because the graph is not shifted left or right. It's starting at 0. So that means it's a sine function starting at 0. So that means that the phase shift is 0. So if phase shift is 0, that's PS is equal to 0, C over B. But we know that B is already 1, so we can replace the B with a 1, and that tells you that that C is equal to simply 0. Because if you multiply, the 1 doesn't make a difference, so that just means that C equals 0. So now we have everything we need to write out our function. We have C, we have A, we have D, we have B. So now we can write out our function. So let's first write the general form. So recall that the general form is y equals A sine bx minus c plus d. All you got to do is replace the letters with the numbers. So y equals A, which is 1, sine b, which is 1, minus c, which is 0. So you don't have to write minus 0. You could just write x, and then plus d, which is plus 2. So that is our final answer. That completes that problem. Let's look at the very last problem on the next page. So it's exactly the same thing. We're expected to write the formula for the function. So once again, let's start with the midline. If you look at the midline, you will see that it is, remember, you can also take the maximum point minus the min times a half. That was the formula on the first page or the second page of the notes. The maximum is 8. The minimum is 0. So 8 minus 0 is 8 times 1/2 is 4. So that's another way you can find the midline. Or you can just simply look at the graph and kind of figure it out that way. It's the point that's in between the max and the min. So here we go. Let's draw our midline. Very good. Y equals 4 is our midline, so that's our D. D equals 4. Okay, now let's go with the amplitude. The amplitude, or the A, the way you find A is simply by counting from the max to the midline, or subtracting max minus midline. So that would be max is 8, midline is 4. The distance from 8 to 4 is 4. 8 take away 4 is 4. So that is our A. Then you got to determine whether it's positive A or negative A. That's given by the direction. Does it start going up from the midline, or does it start going down from the midline? So notice if this is our point at which we start, it's going to go up first. Therefore, it's going to be positive 4. If at this midline point, it went down first, then this would have been a negative 4. All right, So now let's figure out what b is. So for b, we have to use the period formula, which is 2 pi over absolute value of b. I'm just going to put b. You don't really need the absolute value in these situations. So let's find out what the period is. It looks like from the graph itself, if we start here at this point, that looks like it's starting at 1 and it ends at 11. See this point here? That corresponds to 11. So it starts at 1 and ends at 11. So from 1 to 11, that means the period is 10 because you subtract. So the period is going to be 10. And now we can solve for b. So once again, the way I got 10 is because I subtract the last point from the first point. The last point was at 11, and the first point was at 1. So that's 11 take away 1 is 10. That's our period. Now we can multiply both sides of the equation by b and solve for b this way. Cancel, cancel. So now we have 10b equals 2 pi. Divide both sides by 10. Little algebra. B equals pi over 5. So now we have our b. We have a, b, and d. The last thing we need is our c. So let's figure out c now. So for c, you need the phase shift. So the phase shift is given by c over b. So notice that the graph starts here at 1. So it's shifted to the right 1 unit. So that means that your phase shift is positive 1 because it starts at 1. It doesn't start at 0. So now we can replace the phase shift with 1 because that's what it shifted. It shifted 1 unit to the right. And we already know b is pi over 5. So c over pi over 5. Now we need to solve for c. The way you solve for c is you multiply both sides of the equation by the denominator. And that's how you isolate c. So that's just going to be c equals pi over 5. And now we are done. Now we can just put it all together and we can write out our function. So we have our a, b, c, and d. We are good to go here. So remember that the general form is y equals a sine bx minus c plus d. And now you just have to replace the letters with the numbers. So a is 4, b is pi over 5. Don't forget the x. Minus c. C is pi over 5 as well. And d, which is 4 plus 4. So here we go. Our final answer is that function there. All right, we are done with 8.1.